Hello children, I am Vijay Kumar, Physics ARP, Sri Chaitanya Techno Schools. Today we are going to learn a new lesson named Human Eye and Colorful World. This lesson enables us to understand some natural phenomena that happens in our day-to-day life. Coming to the weightage part, this lesson carries around 7 marks in CBSE board exam and about 5 to 6 marks in our both state AP and Telangana state board exams. Not only that, in NTSC we will get 2 marks from this chapter, and some important concepts like dispersion, scattering are already covered in our 9th class techno program and 9th class icon program and C batch program also, and in 8th class IPL program. So, this lesson is very important for all category students. Before going to the detailed explanation of this lesson, I would like to ask you 3 questions. First one, we all have seen the beautiful color of sky, right? What is the color of sky? Yes, blue. Have you ever think why the color is in blue only? Why is it not in your favorite color like green, yellow, red, etc., etc.? And coming to the second question, we all have seen the color of sun at the time of sunrise and at the time of sunset also. What is the color of sun at the time? Yes, it's red. Again, why is it in red? Now, coming to the third question, we all will enjoy to see the beautiful colored pattern on the sky after a rain shower. What is that? Yes, rainbow. What causes it to form like that? Not only these things, but we all are blessed with a very important part in our body to see this colorful world. I hope you guessed that. What is it? Yes, eyes. But some people will suffer from some defects of vision like short sightedness, long sightedness, cataract, color blindness, like that. What are the reasons for those problems and how they can be corrected? Regarding all these information we are going to learn under this chapter. So, dear children, let us get into the topic. Children, this lesson can be mainly divided into 3 parts. In the first part, we discuss about the structure of human eye. There we will discuss about the parts in the eye and their functioning. And in the second part, we discuss about the defects of vision and how they can be corrected. And in third part, we discuss about the dispersion of light and scattering of light and some applications of these 2 phenomena. Under the first concept, structure of eye, we are learning this concept, that is least distance of distinct vision. To understand this, let us do a small activity. Now, take a book or notes in your hands and hold that in a position like this and try to bring it closer to your eyes until it is very close to your eyes, in this, maybe in this position. So, at this position you hardly read anything because the letters appears blurred, and if even more you try, your eyes will feel strained, isn't it? Now from that position, move the book away from your eyes and hold the book in such a position where the letters are clear and you can see the letters comfortably. Hold the book in that position and ask your friend to measure the distance between your eye and the book. Okay, note that value down and repeat the same activity with 2 or 3 of your friends, and in each case measure the distance. Finally, what you can conclude is, to see any object comfortably and distinctly, we need some minimum distance from our eye, and this distance is called least distance of distinct vision. So, now let us define this least distance of distinct vision. The minimum distance from the eye to see any object comfortably and clearly is called least distance of distinct vision. And you will find that the value of least distance of distinct vision is about 25 centimeters for healthy human eye. And this value of 25 centimeters will vary with the age groups. That means, for children under 10 years age, they are having eyes with the flexible muscles and strong enough, so they can read the things somewhat closer than us. You might have observed that at your home. Children of 3 and 4 years age, they will look the mobile phones by keeping them very close to their eyes, isn't it? And the people who are old age people, for them the eye muscles are not flexible and not strong enough. So, for them this value of least distance of distinct vision will move to a greater value, about 1 to 2 meters. Let us now discuss about the structure of human eye. See, this is the structure of eye, and this is the schematic diagram of the eye, which shows some basic components of eye. Here let us see them, the parts of the eye in detail. First, the structure of eye is spherical, whereas the front portion of the eye is little more curved, and this is the portion which is visible to the outward, and this will be the inside. Okay. Now, this portion, front portion, what we are saying more curved, is protected by a membrane called cornea. This membrane protects us from outside atmosphere like dust and everything. And behind this cornea, this region is filled up with a fluid called aqueous humor. Okay? And aqueous humor function is to nourish the eye. It will provide the nutrients to the eye. And behind this aqueous humor, you see a lens here, we call it as eye lens, and between this eye lens and aqueous humor, you are observing a muscle, a strong muscle, we call it as iris. Iris is the only colored part in the eye, where at the center of this iris there is a gap, there is a hole in between the iris, exactly at the center of the iris. You can call it as pupil. Okay? Pupil. Pupil is the hole actually, which is in the center of the muscle iris. Now, let us discuss this pupil and iris in detail. You can see some pictures here on the screen about different eyes. You are observing the eyes of having different colors. Some are having green colored eyes, some are having brownish colored, some are having blue colored eyes. In India, most of us have black colored eyes. The color of eye is nothing but the color of iris. At the center, you are observing a black spot, right? That is called pupil. Wherever the pupil lives, the center, the pupil appears in black. You know why? Yes, whatever the objects that we are observing, that we are watching, the light from that object will pass through this pupil into the eye. Once again, I am repeating. We all know that to see any object, light should fall on that object, and after reflecting from that object, the light will enter our eye, then only we can see things, right? Okay. And that light will enter the eye through this pupil only. Okay. And the light that is entering through the pupil is not going to reflect back. That is why we won't see any color of pupil. The colorlessness is called black. To make it easy, to let you understand this, I will give you a small example. We all have seen the background of space, right? It is in black color. You know why? From the beginning, way back from the beginning, plenty of stars which are producing light in different directions is continuously going on with enormous speed that we know, that is about 3 lakh kilometer per second, right? And the light which is emitting from that stars is going on continuously, and it is not reflecting back. And we know that is why we say that space is that much huge. Okay. Light that is going continuously will not come back. If there you find any edge for the space, then the light would have hit the edge and it will come back, then we can say that there is a border or something is there, that is the color of that. We could have say like that. But if light is not reflecting back, then you cannot see any color for that. That is why the center spot up in the eye appears in black. Let us learn about the working of iris. Iris is the only colored part that we learned earlier, and the function of iris is to regulate the amount of light that enters this eye through the pupil. I will make you understand it clearly. Let us suppose this portion is iris and the hole in between the iris is called pupil, right? And to see any object, light should enter through this pupil only. Okay. Now, if you are in outside, that means in bright light condition, the light that is coming from the object is very intensive. So, if more amount of light have entered, then it may damage the rarer portion, that means eye. So, what iris will do is shrink its size so that the whole size will be minimized and less amount of light will go through the pupil. And if you are in dim light condition, then to see objects clearly, the iris will increase its size. So, the size of pupil would increase and more amount of light from the objects will enter through the pupil, then you can see the objects clearly. In this regard, you may get some questions like this. You woke up at night 12 o'clock, you hardly see anything. When you switched on the tube light, you will shut your eyes because of not able to seeing the light, right? So, such kind of questions you may ask in exams. So, let me explain you that. In midnight at 12 o'clock or something, you woke up. At that time, there is no light in the room, that is dark, and you search for the light, I mean the switch. You went there and switched on. Immediately after glowing the bulb, you can't see the light, because whenever you woke up, as the room is very dim, to see the object, your iris would have increased its size to allow the more amount of light through the pupil. When you switched on the light, immediately after glowing the light, more amount of light will try to get in. So, I can't bear the light. So, what you will do is immediately shut your eyes. Why to shut your eyes? You know what? Iris is the one which works a little slower. It works like a tortoise. It can't do its work faster. Okay, the contrast of this situation is also possible. That means, if you are in a bright light condition outside somewhere and you try to move into a dark room like a movie theater or something, in that condition, after immediately entering the room, you hardly see anything. Of course, some light is there inside, but you can't see anything. You know why? Let me explain you. When you are outside, your iris has shrinked its size to let less amount of light through the pupil, and immediately after getting into the dark room, then we learned earlier that it won't expand or shrink its size faster. So, what happens is you can't see anything because the size of the pupil is very less. After a while, it adjusts slowly, then pupil size will increase and light will go through this. So, you can see objects clearly. This is all about working of iris and pupil. Now, let us see the next part, that is eye lens. Eye lens is convex in nature, and whatever the light that comes and hits the eye lens will refract and meets here on retina. The rarer portion will be covered by a very sensitive membrane, we call it as retina. It acts like a screen, and we already learned in our refraction lesson, the images here will formed by this convex lens are real and inverted. To see any real image, we need a screen, right? Yes, here retina takes that part. It acts like a screen to enable us to see the objects. Remember, the image that forms on this retina is a real image, and the distance between eye lens and retina is about 2.5 centimeters. The distance between these two is 2.5 centimeters. And so you can clearly understand here that we are saying the image forms here on retina, and the image distance is also 2.5 centimeters. Is that clear here? Good. The distance between eye lens and retina is 2.5 centimeters and is nothing but the image distance is 2.5 centimeters. Let us go back to our previous knowledge regarding convex lenses. Here, for the case of convex lenses, when you are trying to see an object at long distance, you know that light rays will go parallel to the principal axis, isn't it? After refraction through the convex lens, the rays will meet at a point and we call that point as focus. And you know the distance between this optic center and focus is focal length. Okay? Now compare that situation here in our eye. Whenever you see an object which is at long distance, the light rays will come and parallel to the principal axis, and after refraction they will intersect here on retina. So, we get an image that is real inverted, and we learned that distance between these two is 2.5 centimeters, that we called as image distance, right. And in other words, we also can say, as the lens is convex here and the distance is 2.5, this the point on retina where the light rays are intersecting is focus. So, you can also conclude that eye lens focal length is also 2.5 centimeters. Here in the convex lenses, you already learned that different object positions, we get images at different position, isn't it? See, when object is at infinity, that means object very far from the lens, image will form at focus. And when the object is beyond 2f, and we observed that image formed in between f and 2f. And when the object is at 2f, an image also formed at 2f, right. Like that, when object position is changes, whenever object position changes, image position is also changing. That is what we learned in the previous lesson. But here see the beauty, eyeball shape is not at all going to change. That means the distance between eye lens and the retina is also not going to change. This distance we learned already what? Image distance. Here image distance is not at all going to change, but what about the object? Object distance. Object distance is varying. For suppose you are observing the board now, after a while you will observe your notes. That means in this case object is the board, your notes is the object. In these two cases object distance changes or not? Yes, changing. But image distance is same, it is not going to change. It is always fixed. Whatever the object position, image distance is fixed. What you are saying? Here what we learned is object position changes, then image position should change. But here object position is changing, but image position is not changing. We know lens formula, that is 1 by f is equal to 1 by v minus 1 by u. F represents the focal length of the eye lens, V represents image distance, U object distance. In this case of formation of images, we just learned that object distance varies and image distance also varying because focal length of the lens remains constant. Here in our case of eye lens, object distance is varying, okay, but we are saying image distance is fixed. How it is possible to make the image distance fixed? The only way to change the focal length. How could the focal length of the lens change? To understand this, let us take the help of lens maker's formula. 1 by f is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. This is what we call Lensmaker's formula. It helps us in understanding the factors on which the focal length depends. Here see, focal length depends on refractive index of the lens medium and N1, that is refractive index of the surrounding media, and R1, R2, that they are curvatures, that is radii of curvature of the lens. On these factors focal length is going to be dependent, where N2 and N1 are not going to change in the eye. So, the only possibility to change the focal length is to change the radii of curvature. Can the radius of curvature of eye lens be changed? Yes, see the beauty here. Our eye lens is hard at the center, and when you are moving to the outer edge, it appears fleshy. So, focal length depends on radius of curvature. You can change the focal length by changing the radius of curvature. Like, see, when you try to see an object which is at long distance, in that case, your eye lens will expand its focal length to its maximum value. And when you try to see a nearby object, that is a closer object, then your eye lens will reduce its focal length by changing the radius of curvature like this. Now, so like that you can see object at any distance now. When you try to see object at long distance, focal length can be changed, and again when you are trying to see a nearby object's focal length change accordingly. Now, the problem is, now the question is, who is taking the responsibility to change the focal length of the eye lens? That will be done by an important part of the eye, we call it as ciliary muscles. A strong muscle which is attached to the eye lens will help us to change the focal length of eye lens. When you try to see long object at long distance, it will expand the eye lens so that focal length will increase. When you try to see nearby object, it will compress the size of the focal length, size of the eye lens to decrease the focal length. That will be done by ciliary muscles. Like this, the changing of focal length of eye lens in order to see objects depending on position of object, we call it as adjusting the focal length, will be called as accommodation of eye lens. Accommodation of eye lens. I am repeating once again, adjusting the focal length of the eye lens to see objects clearly, that means to form image on retina for each time, is called accommodation of eye lens. That will be done by the muscles called ciliary muscles. Ciliary muscles are helping us to see objects at any distance, and ciliary muscles cannot diminish the focal length or diminish the eye lens, that means it cannot minimize the focal length after a certain value. Now, you would have understood that why the minimum distance is required to see any object, and you learned that to see any object clearly and comfortably, there should be some minimum distance from the eye lens. You know why? When object is at least distance, that is about 25 centimeters, then ciliary muscles will compress the eye lens to reduce its focal length, and it has a certain limit. Because of that limit, it can comfortably seen, eye lens can comfortably forms an image on retina only when the object is at 25 centimeters. If you come even closer, then ciliary muscle cannot compress the eye lens, so you will feel the strain. Now, let us try to understand the rarer portion of this eyeball. Here, and we learned earlier that this part is named as retina, and this is acting like a screen. The light rays that are falling on the eye lens, after refraction it hits the retina, and retina acts like a screen. Whenever the light rays will fall on retina, then only you can have a clear image, because retina will have 125 million number of receptors. They are called as rods and cones. Rods and cones. Here rods receives the intensity of light and cones observes the color of light. If the problem is with the rods, so they will suffer from night blindness. In dim light condition, the light will not the light that is entering from the pupil will not be intensive. So, these people who are having problem with the rods cannot see objects clearly, we call it as night blindness. And if the problem is with the cones, that means maybe less number of cones or something, then they cannot identify the colors properly. So, we call it as color blindness. So, the light that is falling on retina will be received by rods and cones in the form of electrical signals, and these electric signals will be sent to the brain by means of 1 million number of optic nerve system. These optic nerve fibers will take the information that is received by the rods and cones on retina to the brain, will interpret the information that what we have seen. See, I already told you the image is forming on retina is real and inverted, but you see the object in upright position because of the brain will do that work.